network and the GPON network. The first one that was installed at the beginning, as we said, is based on ATM and will transport everything by means of ATM cells. The maximum bit rate downstream was 622 megabit per second, and the maximum splitting ratio was 32 ways. The GPON, which is an improvement, works according to the general frame procedure as a protocol which is like the general framework procedure, and can transport both data under the form of Ethernet packet or telephone service under the form of time division multiplexing. The maximum split is 64 ways. As you can see here, there are two different parameters reported in the slide. This is the maximum reach, which is 20 kilometers, and we already know it. The other one is the 20 kilometers ONU differential. This means that the maximum difference between the longest distance from the central office and the shortest distance of central office should be less than 20 kilometers. Due to delays, amplitudes, but we shall see it in a minute. Yes.
Confused about splitter.
This is the simplest way to build a 1x2 splitter. I take another 2 and I put here on this I have 1x4. I take another 4 and I have 1x8. I simply put this elementary splitter 1x2 in cascade. But I can do another way, and this is the way they now do it. They put a bunch of fiber all together, they fuse the fibers, and they have 1 to n fibers output. You can get also 1 to 3 or 1 to 5, 1 to 7, which is not the power of 2. But this is only a physical problem, how to construct a split. Have you the intention to set up a farm to build splitters? But if you go on the internet and you look for fiber splitter, I think that somewhere you will find a detailed explication of the technology. But the basic technology is to put 2 fibers together, to fuse them by means of an electrical arc. You enter here, you exit here and here. You remove this piece of fiber and you have a splitter 1x2. If you put several of them, one after the other, at the end you will get 1 to n, where n is the power of 2. You are not convinced?
What you should understand is that from OLT, it's like you are broadcasting.
Yeah.
You broadcast the information. You broadcast a packet which contains a lot of information going to different destinations.
But
the packet is the same. When it arrives at the splitter, the same packet goes to all ONT. Then each ONT will take what it's part of information.
But I beg you to be a little bit patient. We have at least 6 or 7 slides. dealing with the packet replication, which means broadcasting. We are sending the information to everybody, and every ONU selects the information which is for it. Only the information which is for it. The other information are thrown away because are going to other. But you have the same in a TV receiver. From the antenna on the roof, you receive 40 channels. It's a broadcast. You select the only one you want to see. So this is the ONU. It receives, let's say, an SDH framework, and it extracts from the SDH framework only the packets that are sent to it. As I was saying just before, the PON stays for passive optical network, but we have an example in which we can insert a rich extender, which means we can put an active element in the fiber plant in the outside to have a longer reach, which means up to 60 kilometers. As you can see, I start as usual from the OLT in the central office. I reach a remote site which need to be powered, so I should have power feeding there. I have a receiver and I retransmit. What I am doing in simple words is to have a replica of the OLT at a distance of 40 kilometers from the central office. All the rest is exactly the same. What's the reason for having longer reach? The main reason is what is called consolidation or concentration, which means that I can start all my passive optical networks from the same central office. Imagine you have a large city and many central offices. You can develop a passive optical network here, 1 year, 1 year. This means that you have to be interconnected to the metro access network here, here, and here. As an alternative, you can have long reach, which means I start from here, I put the reach extender and I go here. I start from here, I put the reach extender and I go here. I start from here, I put a reach extender and I go with the passive optical networks. Now I have all the networks converging in a single central office, and I connect only this central office to the metro access network. So this is a process which is called consolidation or concentration. The PON standardization and deployment started after a period in which other architecture to have the fiber very near to the homes had already been studied and in some cases deployed. So the original names for those technologies were fiber to the X, where X means something between the central office and the user. So that we can have fiber to the home, FTTH, fiber to the building, fiber to the curb, fiber to the cabinet. In each of these 4 cases, we have to put at the end of the fiber plant an ONU. In the last 3 cases, the ONU is in the space between the user home and the optical line terminal. In the first case, the ONU is deployed at the subscriber premises and the name changes to ONT as we saw before. Typically, the last stretch to the subscriber premises, the last few meters or hundreds of meters, are deployed as part of the copper network, and the information is transmitted by means of mainly ADSL, but also VDSL or other XDSL type connection. These are the architectures. You can see central office. In the last 3 cases, in these cases, we have fiber plus ONU plus copper. There is also a variant which does not seem very clever and has everything which is optics inside the central office, and we can go with a copper pair from the central office to the houses. FTTA stays for fiber to the exchange, which means that the exchange itself could host one or several ONU, but it is normally not used. Data rate that can be achieved by means of the new XDSL technologies. It depends, of course, on the length of the last stretch, and we can see that if we have an optical network unit which is very close, less than 2 kilometers or maybe a few hundred meters from the house of the customer, we can reach data rate as high as several tenths of megabit per second. So this is a comparison of the various technologies that can be bought nowadays from vendors. And this is a status not very recent, to be honest, but it is a status of the various ITU recommendations dealing with XDSL technologies. Well, now we start the hot part of the presentation, and I think that it's better to stop here to have a coffee break. We shall resume at 4 o'clock sharp, please. Well, before starting again speaking about GPON, we have a splitter from the real world here, not from the paper, and you can have a look of it. It's a splitter with 32 outputs and 2 inputs, one working input and one protection input. Pay attention because it is very fragile. And now we start speaking about protocols, which means how the system actually works. Because we said there is a downstream direction, an upstream direction, but it is not well clear how data can reach their final destination and how data can be sent back to the optical line terminal. In the left part of the slide, we can see an optical line terminal which is sending 3 different packets, A, B, C, to the 3 destinations we have in the network. As you can see, at the splitting point, which is, I repeat, poorly passive, all the data is replicated to each fiber output. As you can see, ABC, ABC, ABC are reaching the 3 different optical network terminators. At the end, each one of the optical network terminator extracts its own information, which means that ONT number 1 will extract A, ONT number 2 will extract B, the third one will extract the packet C. This poses a series of problems, the most important of which is confidentiality. We are sending information that can be reserved information to everybody. So, for example, if I have an hostile person and I get access to ONT number 3, I receive my information, which is C, but I have as available also the other 2 information, A and B, and eventually I can collect them. This is resolved in a very simple way with cryptography. Any information is secured by means of passwords, so that each ONT or each ONU can have access only to its own data. On the other direction, the upstream, we have the different ONT sending their information. There is something that must be clear, that in this case, the information must be sent with the appropriate timing to avoid that 2 different packets arrive to collide in the splitter. So if we want to respect the fact that the packet should avoid collision at the splitter, we have to give the network the right timing. Moreover, even if the 3 ONT in the picture could seem to be in the same position, actually they can be at very different distances from the splitter, which means the first one could be at 5 kilometers, the second one at 8 kilometers, the third one at 12 kilometers. That means that the signal will arrive at the splitter with different amplitudes. as you can see here, you have that the signals are different in amplitude. This is not a very good situation, so that care should be also taken to avoid the fact that OLT receive packets which are very low in amplitude and packets which are very high in amplitude. But we shall see it in a moment. So, what is the main point in this slide? Downstream is very simple. The packets are sent by means of time division multiplexing to everybody. They are broadcasted. And each ONT or each ONU, depending on the location, select only the information which is its own information. On the other direction, which is upstream, we have ONU sending packets at the right time and possibly with the right amplitude, which means that the ONU, which are very close to the splitting point, will reduce the laser power in order to decrease the amplitude of the packets, of the signal carrying the packets. We shall see in a second how this can be done. And moreover, since we want to avoid collision, the ONT or ONU will be instructed by the optical line terminal regarding the timing for sending packets, which means that there is a protocol giving a reference clock to any of the ONU. Another thing is that the bandwidth can be allocated according to the needs, to the requirements from ONU, and according to the service level agreement, to the contract. Maybe some ONU have a bandwidth which is 2 times or 3 times the bandwidth of the other. It depends on the customer. If you are a bank or an enterprise or a small office, you can get paying more, of course. You can get more bandwidth so that in the upstream you can have twice packet coming from B. The packet B can be twice a double number with respect to packets A and C. So, to be more precise, the downstream flow is a TWDM flow, time division multiplexing flow, and there is no gap, so no bandwidth is wasted. There is wasted. There is no waste between. There is no time guard interval between packets. If there is nothing to transmit, the OLT will generate idle packets, idle cell, to have a continuous data flow in order to allow the optical network terminator or optical network unit to recover directly the clock from the downstream data flow. The upstream works in a so-called burst mode, which means that the packets are sent according to burst, and the cell or packets reach the splitting point, that is the optical line terminal, since from that point they share a common path, with different amplitudes. A suitable guard time to avoid collision is guaranteed by the media access control. OLT receiver is able to recover the clock even if no ONU is sending packets, which means that there could be long periods of silence. No packets is sent to OLT. As I was saying before, the bandwidth can be allocated according to the requirements or according to the contract between the operator and the users. In this case, we put into operation an algorithm which is called dynamic bandwidth assignment, which means that the bandwidth is provided to the ONU dynamically, which means at 4 o'clock it can be 100 megabit per second. At 5 o'clock it could be 80 megabit per second because the user has nothing to send. We have we have more than two, but ITUT has standardized two different types of passive optical network. The broadband one, the BPON, which is based on ATM, and the GPON, which is able to transmit the data at gigabit rates. Ranging. This is an important part of the protocol. I told you that the ONU could stay at different distances from the OLT, so that a mechanism should be provided by the protocol to understand what is the real distance and what is the proper timing for that distance. What I mean? I simply mean that we are commissioning the system and we are going to put an ONU into operation. We connect the fiber to the ONU, we power on the ONU, and just after we will have exchange of information between the ONU and the OLT. By means of this exchange of information, the OLT will be able to evaluate the distance of that ONU and communicate the distance to the ONU so that it is able to reduce or to increase the power of the transmitting laser and to fine-tune the timing. That is the phase according to which the packets have to be sent. The actual delay is computed during a ranging process that takes place at first when we commission an ONU, afterwards anytime we switch on the ONU, and continuously, because we can have some changes in the parameters according to which the delay may vary because of temperature, rain, aging, and so on. In this case, sometime during transmission, the OLT will use the ranging protocol to check if the parameters that are stored are still valid or are to be changed. Ranging process is very important because if the accuracy of the ranging process is very high, the time interval, the time guard interval can be reduced. And this means that the total bandwidth will be increased, which means to increase the efficiency of the system. during the ranging procedure, some assumptions are made. The first one is that not necessarily the upstream delays are equal to the downstream delays. And moreover, the delays can change during the life of the system due to environmental changes or component aging, so that periodically the ranging procedure must be repeated. These are some details about the ranging procedure, the ranging method. We have the initial ranging and the continuous ranging. The initial ranging is initiated by the OLT by stopping any other ONU except the one under test. This is to simplify the measurement, because in the passive optical network there will be just one ONU which is transmitting, and the signal will be very clear and can be tested very easily. And we have other phases, but I already spoke about them, so you can simply read them and understand what's the meaning. The dynamic bandwidth allocation is required because ONU can have a different number of customers connected, or some customer could require higher bandwidth because they are the enterprise or banks or small and medium offices. What are the goals of the algorithm, the dynamic bandwidth allocation? To use with the maximum efficiency the bandwidth of the fiber plant, to introduce a minimum delay between the users and the OLT, and to introduce a criterion of fairness and respect of priority, which means that if a given user stays in the queue, it is not fair to him to let he wait for his turn, so it's better to give him more bandwidth. This is a collection of some values which are appearing in the two series of recommendations dealing with broadband passive optical networks and gigabit-capable passive optical networks. As you can see, the regs are in the series G.983.x, where X means 1, 2, 3, 4, 5. The same applies to the following recommendation series. For the broadband, the maximum foreseen split ratio is 1 to 32, which is exactly the splitter we saw before, and the maximum reach is 20 kilometers. For the GPON, the bit rate is increased to 2.5 gigabit per second downstream, 1.25 upstream. The split ratio, the maximum is 1 to 64, with a potential of 1 to 8 if I can, by other means, reduce the attenuation of the fiber by 3 dB, and the reach can be up to 60 kilometers with the reach extenders. The first headline in the slide, passive optical network plus systems plus WDM is a little bit misleading. I am sorry about it. WDM is not used at large in PON networks. It is used only to multiplex the three wavelengths you see, but is not used to have different signals on different lambda. You are the expert in this field. Could you understand what I am saying? I will repeat. Okay. I have here the optical line terminal. I must send data at 1.55, 1.49, and I must receive data at 1.31. If I like to avoid losses, I put here a WM multiplexer, and I get here the two lambda which are going downstream, the one which is coming upstream with no losses. This is the meaning of WDM on top of the slide. I could also use WDM to connect a different OLT on different wavelengths. Let's say 1.454, 1.48, 1.30, and to use the same to send more information and to receive more information. This is not used with only one exception, which is Korea. South Korea is using WDM PON. This is the schematic diagram from ITUT recommendation, which is the equivalent of the slide I have been showing you before with the small houses and the copper lines and so on. This is the standard, and as you can see, on the left-hand side, we have the optical line terminator. On the right-hand side, we have the home network, which is the network of the customer inside his own home. And we can have the fiber reaching the home or reaching some point in the open air, and from here, reaching the home via copper pair. We already saw the concept, we already saw the pictures. This is the reference diagram. Again, terminology. We already saw it, and I must insist on this one. When the ONU is inside the customer home, we speak about ONT, optical network termination, since the ONU and NT will form a unique equipment. Service categories. We have an optical or mixed access network. Which kind of services can we deliver of such a network? We can have asymmetric data broadband services. which means that the information flow from the central office to the customer is much higher than the information flow from the customer towards the optical line terminal in the central office. This is the most common situation that we have every day at our homes, for example, since we, as internet browsing users, normally we send a short request to the server, please connect me to the Microsoft in Seattle, and we get back a lot of pages to be consulted, or we download files, or we can download music or movies, and so on. This is an asymmetric service because, as I just told, the data rate in one direction is much higher, typically 8 times, 10 times the data rate in the other direction. Symmetric data broadband service. This can be requested, for example, by important customers. If you have a bank, the bank will exchange information with other branches of the bank so that the data rate can be expected to be the same in the two directions. The access network should also be able to provide narrow band telephone services, which means that the old telephone line is removed and everything is done over the access network. This is, for example, the situation with some newcomers, with some operators that joined the market a few years ago, and they started building their network according to the rules of an IP network. They offer telephony, but it's voice over IP telephony. Pay attention to the fact that if telephony is intended as a universal service, which means that you should be able to make a phone call from your house at any time, in any condition, voice over IP can't ensure universal telephony, because if the power line, if you don't get electricity at home, voice over IP will stop working. And if you need the telephone because it is an emergency, you will not telephone, of course. And the access network could also be used to collect many ADSL channels to be sent over the same fiber, which means can operate as a DSL backhaul. This is a table with a scenario for fiber to the building deployment. We can have in the building, we can have multi-dwelling units, that means many apartments, or we can have business units, and you can see that normally a business unit requires symmetric data rate and a private line and POTS stays for plain old telephone system and ISDN. While the apartments normally call for asymmetric data rates, and they don't have any need to have private lines. In Well, this is the same as before. Architecture. How the optical distribution network, which I recall is fiber plus splitter, plus any other passive optical components, for example, connectors or splices. What is the architecture? The relevant recommendation is in the L series of recommendation, which is dealing with optical fiber cables and cable installation in general, and list several possible architecture, which are mainly point-to-point and point-to-multipoint. The point-to-point architecture is future-proof because any customer has its own fiber and you can upgrade very easily the data rate or the service which are provided. But since any customer has its own fiber, the total fiber length in the network will be much higher than in passive optical networks with the splitting units in the field. So that the point-to-multipoint, which is one feeding fiber plus splitter plus branching fibers, is preferred for lower cost. We shall consider in the following only gigabit passive optical networks, since they are in line with broadband passive optical networks, so that it's better to speak just once of the same things, and point-to-multipoint architecture. This is the point-to-point architecture for the optical distribution network. As you can see, any customer, which means any ONU, has its own fiber and its own OLT in the central office. Of course, since you have no splitting at all, the optical loss will be confined to the loss of the fiber. Even if you have a 20 kilometers fiber, the optical loss will be 8 dB or less. There is no resource sharing. Any customer gets its own link. This means that large distances can be reached for links between the central office and the customers. The customer can be given the bandwidth they want because on an optical fiber which is not shared by many users, you can provide 1 gigabit per second, 10 gigabit per second, or 40, or in the near future, 100 gigabit per second. The problem is only the cost, of course, but any customer has its own infrastructure. This is the point-to-multipoint. As you can see, we have fibers plus branching components, and the branching component can be everywhere along the path. It can be in the central office, top slide, can be in the field, can be in the building, inside the building. Of course, if you add all the length of the fibers, you can see that the average length per user is much less than in the previous case. This is the reference scheme from the relevant ITU recommendation for the interfaces. This is the optical distribution network, which means fiber plus splitter. This is the optical line terminal. Just after the optical line terminal. I have the standard interface S and R, which are sending and receiving interface, which are the complement of the RS, receiving and sending interface, just before the ONU. And moreover, I have also optical interface, which means not only electrical parameter, but also the wavelength that are to be used by the optical line terminal and by the optical network units. Position of the branching unit. If I am designing, I don't have. No, it was Makoto's on remote control. And you should have also the receiver on the PC. I don't have. I will buy one as soon as I go home. I am designing an optical distribution network. The problem is where I have to put the branching unit or the branching units, if they are more than one. Well, of course, it depends on many parameters, which are the number and density of customers, including the forecast on the future demand, the network scalability, which means how many fibers will be terminated immediately and how many fibers will be left dark, which means without no ONU attached before new customers arrives in the area, and what is the total fiber length of the network, etc., etc. Another parameter which is very important is the optical transmission performance, which means which kind of fiber I have already deployed or I am going to install, what is the attenuation range, which is the class of the system I am going to install, what is the differential optical path loss, that is the difference between the maximum attenuation I have in the ODN and the minimum attenuation I have in the ODN. What is the return loss? Return loss, it's a new concept. We find it here for the first time. It's the loss that is due to reflections. The light in fibers, if a joint is not very good or if a termination is not very good, is reflected back. This can be measured and it is normally called reflection, return loss. Dispersion, chromatic dispersion, and this performance will be used in the design in accordance with the two series of recommendations I have explained before. Multi-stage configuration, which means more than one splitting level, are better than just one splitting level. But please do not exaggerate. One is not very good, two is good, three is less good than two. This was the first topology to be used during deployment of passive optical networks. I must confess, frankly speaking, that I don't see any advantage in this use because we have all the fibers running from the central office to the ONU, which means that it is exactly like a direct link between customers and central office. The only two advantages I can see are the sharing of just one OLT and the fact that the branching component, I mean the splitter, is in good environmental condition because it is in a central office and it stays in air conditioning environment and so on. But as you could see before, it seemed to be a very robust component, so you can also lay it in the street without any problem. Here we have the splitting device in the building. You can have a lot of ONU inside the same building, and you can reach the building with just one fiber, and afterwards you can split the signal. This in a future-proof vision, this will be the preferred architecture since you will reach the customer with an optical fibers, and you will minimize the cost of the plant since you have just one optical fiber running from the central office to the building. Life cost, which means the evolution of the optical distribution network. Well, I am not a real expert in this field, so I will limit myself to give you some information that I could collect. In the deployment of a new network, we can distinguish 4 different phases. There is an initial stage, a growth stage, a mature stage, and a final stage. Which means that we are going from the first installation, we are building the network, but normally no one wants the service, so you are building the network, but you must also find the customers, to a period in which the customers will grow because they recognize the importance of the service you are offering. Afterward, there will be a stabilization period in which you have reached all the customers interested to the service in that zone. Afterwards, you will have the final stage in which the number of the customers will be decreased eventually because your service is getting old and the customers will switch to different services. Imagine you are a provider of analog TV channels over cable. If the competition uses a different distribution scheme and the channels are digital one, at a given point in time, your network will not interest, your service on that network will not interest anymore any customer. So that there is a declining phase as reported in the figure. But the network is not dead, pay attention. It's the service that is not required anymore. The network is still there, it can be reused for different services. Think about ordinary telephony and XDSL. nobody, at least in some countries, wants any more new deployment of wired telephone lines. It's very common to have only the mobile phone because having a fixed line is costly and moreover you are binded to an operator or to a service. But the plain old telephone systems was not destroyed. It was used to provide new services, which means ADSL and the like.